The minimum force required to break a cable is normal with mean 12,432, standard deviation 25. A random sample of 400 cables is selected. Find the probability that at least 349 of the selected cables will not break under a force of 12,400. So if we look at this question part of the problem, we recognize that the number of cables that will not break under a force of 12,400, that variable is a binomial variable. N is 400 because 400 total cables, and we have to find the probability that at least 349 will not break under a force of this. So a cable will either break under a force of 12,400 or it will not break under a force of 12,400. So it's binomial. Now, N is very obvious that it's 400. However, the little p is to be calculated. We need to do some work to get the little p, which is the probability of success, which in this case is the probability that a cable will not break under a force of 12,400. So let Y be the minimum force needed to break a cable. If a cable does not break under a force of 12,400, which means that if the force is 12,400 or under it, then the cable does not break. So then that means that the minimum force that is needed to break the cable is greater than 12,400. So since we're calling that minimum force as Y, therefore the probability that a cable does not break under a force of 12,400 is the same as probability that the minimum force needed is greater than 12,400. So changing this, and this is the little p. So we need to calculate this, and we are given that Y is normally distributed by the minimum force needed to break a cable. Minimum force needed to break a cable is normally distributed, and we're calling that as Y. So Y is normal. So its mean is 12,432, standard deviation is 25, and we need probability Y greater than 12,400. So we need to change the 12,400 into standard score. And it's the value minus the mean divided by standard deviation. And we get negative 1.28. So probability Y is greater than 12,400 equals probability Z is greater than negative 1.28, which by symmetry is the same as Z less than 1.28. And from the table, we read that to be 0.8997 against the 1.28. So let's just... So 1.28 is 0.8997. Okay, so we finally got the little p. We already had the n, which is 400, and the reason we need that is that now we need the mean and the standard deviation. Remember, our first remark was that the number of cables that do not break under a force of 12,400 is binomial, and we need its mean and standard deviation because we're going to use normal approximation, since this number is so high that it's just not possible to do it through a normal calculator using binomials. We have to use the normal approximation. So by normal calculator, I meant the usual handheld calculator that we use. So that's just not powerful enough to treat it as a binomial. That's why we need the normal approximation. So the mean of a binomial we know is NP, N is 400, P we just calculated to be 0.8997, so it's 359.88. The standard deviation is the square root of NP 1 minus P for binomial, and that comes out to be 6.01. And therefore, our question was to find So let's read the question again. Find the probability that at least 349 of the cables will not break. So we call that as X, the number of cables that do not break under this force. And we want the probability that X is greater than equal to 349. So now the number of cables is a discrete variable. So therefore we apply continuity correction. Remember, we don't need continuity correction for the continuous variable, which this one was over here, because here it was the force needed, the minimum force that was needed to break a cable. So the force is a measurement, that's a continuous variable. But now we are changing the number of cables that break, that do not break, and that's a count. So that's a discrete variable. So since we're using normal approximation, we use continuity correction, and greater than X greater than equal to 349 means X greater than equal to 348.5 by continuity correction. And therefore we need to change 348, because at least 349 is what they were saying. That means greater than equal to 349, and by continuity correction that means greater than equal to 348.5, because anything that's 348.5 or greater rounds to 349, and this is saying 349 or more. So this is also saying 349 or more if we think of discrete situation. So 348.5, the mean for that, this is the binomial variable. So the mean for that was this 359.88, standard deviation was 6.01. And that comes out to be negative 1.89. So probability X greater than equal to 348.5 equals probability Z is greater than negative 1.89. And that's the same as Z less than equal to 1.89. And from the tables, we see that 1.89 gives us 0.9706. The answers are to 2 decimal places, so this is 0.97. And that was choice D.